So in this video we will create a house price prediction machine learning model by using a random forest algorithm. First we will import necessary libraries. First I will return import pandas as pd. This line import the pandas library. And next I will write import NumPy as np, which is a fundamental package for numerical counting in Python. It's great for working with arrays and performing mathematical operation. Next, I will write from Scikit-learn dot model selection import train test split. This is a crucial one from Scikit-learn, the go-to library for machine learning in Python. The train test split is a function that helps us split our dataset into two parts, one to train our model and another to test how will it learn. And next, I write from sklearn dot linear model import linear regression. Here we are importing the actual algorithm. We will use linear regression. This model tries to find a straight line relationship between the features like area and rooms and the target, the price. And next I write from sklearn dot preprocessing import one hot encoder. Machine learning models understand numbers, not text, like city A or city B. The one hot encoder is a tool that converts categorical text data into a numerical format that our model can work with. Next, I write from sklearn.compose import column transformer. A column transformer is a very handy tool. It let us apply different data preparation steps to different columns. For example, we only want to use the one hot encoder on our location column, and this tool makes that easy. Next I import pipeline by returning from sklearn dot pipeline import pipeline. A pipeline is a fantastic feature that changes all our steps together, like data pre-processing and model training, into a single workflow. This makes our code much cleaner and less prone to error. Next I write from sklearn.matrix import mean squared error and r2 square. Finally, we import some matrix to evaluate our model. Mean squared error tell us the average square difference between the predicted and actual prices, which is lower is better, and r2 squared tells us how much of the change in the price our model can express. Closer to 1 is better. Now we are moving to the main body of our code by creating the data set. Now that we have our tools, let's create some sample data to work with. Here I write data in curly braces. Here we creating a simple Python dictionary to hold our data. We have three features: room, area, and location, and our target variable price. Next, I return df is equals to pd dot data frame bracket data. With this line, we convert our dictionary into pandas data frame called df. This organizes our data into neat table with row and column, which is much easier to work. Next, I write print df head. Print df.head function. The head function method is a great way to quickly inspect our data. It shows us first 5 rows of the data frame. The next I return x equals to df and room area location, and y is equals to df price. Here by convention x represents our features and y represents our target variable. Next I will write building the preprocessing and modeling pipeline by returning preprocessor equals to column transformer in bracket transformer square bracket loc one hot encoder function square bracket location and square bracket complete and reminder equals to pass through. We are creating our column transformer. Here we will tell to apply a hot encoder only to location column. The reminder equals to pass through part is a very important. It means that all other column, room and area should be left untouched and pass through without any changes. Next I write model equals to pipeline steps is equals to square bracket preprocessor preprocessor and regressor comma linear regression function. Now we have defined our pipeline. It has two steps. Preprocessor, the first step will take our data and apply the column transformer we just created. Regressor, the output of the first step is then automatically fed into our linear regression model for training. Using a pipeline is the best practice because it prevents data leakage and simplifies our workflow. In the next line of code, I write xtrain, xtest, ytrain, ytest equals to train test split in bracket x y test size equals to 0.2 random state 42. Here we use train test split to divide our data. Test size is equals to 0.2 means we will use 20% of our data for testing and other 80% for training. Random state equals to 42 is seed that ensure we get some random split every time we run the code, which makes our result reproducible. Next I write module fit xtrain ytrain. This single line is where the learning happens. We call the fit method on our pipeline giving it our training features. Xtrain and training targets ytrain. The pipeline automatically handles the pre-processing and then trains the linear regression model on the processed data. Next I write ypred equals to models predict xtest. After training, it's time to see how well our model perform. We use predict function method on our test data xtest. Next I write print and print predict prices ypred print actual prices list ytest. Here we are simply printing the model's prediction ypred and comparing them to actual prices ytest from our test set. Next I write print mean squared error bracket ytest ypred print r2 square ytest ypred. This line calculate and print our performance metrics. Next I write sample equals to pd dot data frame in curly braces room 3 area 700 location city B. Let's imagine new house come on the market. It has 3 rooms and area of 700 square feet in a city B. Next I write pred price equals to model dot predict sample. We pass this new sample to our train model predict function method. This pipeline takes care of everything. Next I return print slash and print and predict price for sample pred price 0 lakhs. Finally we print the output. The result is an array. So we use 0. Now I will show you the output of the model in a terminal by returning this command which is shown in the yellow color. Here you can see that by returning this the house price prediction model by using random forest algorithm will show this type of output. The